We're going to begin Unit 10 by learning first about what are the properties of acids and bases and what makes an acid acidic and what makes a base basic. So first, the properties of acids are that, ironically, I'm going to start with this one, which is that they taste very sour. Now, why I say that's ironic, because of course you wouldn't think that you would want to actually drink an acid, but surprisingly, a lot of the drinks that we do drink are acidic. Of course, you could think of like all of the citrus drinks, orange juice, and things like that, as well as say you have Coca-Cola. Coca-Cola has phosphoric acid in it. So a lot of the drinks that we have are acidic. Milk, on the other hand, is a little bit basic, by the way. It's going to taste or feel, if you have a weak acid on your hand, say you spill some orange juice on your hand, then it's going to feel very squeaky. What I mean by that, I know that sounds kind of funny, is that your hands will be wet, of course, but when you rub your fingers together, it's going to feel kind of grippy. They don't slide very well. It's the opposite of slippery. So that's the way the acids feel. Now, obviously, you don't want to put a strong acid on your hand. That would be really disastrous. But what we're talking about here, obviously, are your weak acids. If you were to drink them, they would taste very sour, and they would feel very squeaky to the touch. They are going to turn an indicator called litmus paper. They're going to turn a blue litmus paper red. Notice I'm writing in red ink. That is on purpose. So acids are red. They turn blue litmus paper red. Another one is their pH is always going to be something less than 7. So basically that's going to be 0 through 6 on the pH scale. And finally, they react with acids, or excuse me, react with metals. Okay, so you guys have all seen the movies when acid is dripping onto a metal and it, smokes and bubbles and it eats through real quick. Obviously, that's Hollywood and it's a little bit of an exaggeration, but strong acids can corrode and dissolve metals. Again, you guys all know the word corrosive. If you see the word corrosive, that typically means it's going to be acidic. Now, what makes an acid acidic? Oops, sorry about that. Is we have two definitions of what an acid actually is. Our first definition is going to be something called the Arrhenius definition, which is more of the traditional model. And basically what that says is that in the presence of water, when in water, it will release H plus ions. Now an H plus, remember a hydrogen is basically a single proton and a single electron, right? There's no neutrons, it's just one proton, one electron. So if it has a positive charge, it has no electrons at all. So an H plus ion is in effect a proton. Okay, it's just another way of saying that. But basically, if an acid is put into water, if it releases H plus ions or protons, then by the Arrhenius definition, that is a acid. On the other hand, there's these two gentlemen that came up with a definition at roughly the exact same time in 1928. And so their definition kind of, they both get credit. And we call that the Bronsted-Lowry definition. And basically what it is that an acid is anything that donates a proton. Obviously, this is a little bit easier one. So anything that donates a proton. So those are the two different definitions. They are similar, but a little bit different. You do need to be able to differentiate between the two. So do kind of keep those separate. Again, an Arrhenius definition is anything that when it's put into water, it will increase the concentration of H plus ions, where a Bronsted-Lowry is anything that basically donates a proton. Any of those two would be considered acidic. As you guys can see on the little cartoon on your right, that acid is giving away a proton, so that base is going to be quite happy. Now, what makes a strong acid strong and a weak acid weak is the amount of dissociation or ionization. So to dissociate means to break apart. If you have an associate, you work with them. If you dissociate from them, then you separate yourself from them, right? So if you are an acid and you dissociate, then you make ions. So it's also, well, ionization. So those words are not exactly the same thing, but in this context, they are basically interchangeable. So a strong acid is an acid that in the presence of water in an aqueous solution, nearly all of the acid compounds would fully dissociate. And what that means is you would get a lot of H+ ions. The concentration of H+ ions, to say it another way, would drastically increase, making it a very strong acid. So again, here you see in the image, here we have, this is called nitric acid, HNO3, nitric acid. It's going to release that H+ ion in the presence of water, of course, releasing again the ions, H+ ion and NO3 negative. Again, that's a dissociation or ionization. This right here, again, is the acidic part. This is an acid by definition, but really it is only acidic when it is in water and it releases these. If I was to have this, for example, HNO3 in a solid form, that is not actually an acid. Why? Because it is not in the presence of water. So conversely, if I had HNO3 aqueous, that is an acid. This is not. It has to be in water and it has to be able to release this H+ ion to increase the H+ ion concentration. Now, on the other hand, what makes a acid weak is when in the presence of water, not a lot of the acidic compounds will actually dissociate. They will stay associated and they're going to stay together. And again, if we are not releasing these, then we're not going to be a very good or very strong acid. So in this example, we have hydrofluoric acid in the presence of water is going to make some H+ ions, but not a lot. Therefore, that acid is going to be relatively weak, potentially not even dangerous, again, very much like the drinks that we consume and some of the foods we eat. There are 7 strong acids. You guys need to be aware of these. There are 7 strong acids. We have in order, let's see, what would that be called? I cannot think of the name of this off the top of my head. We have a chloric acid, we have hydrochloric acid, hydrobromic acid, hydroiodic acid, sulfuric acid, and nitric acid. Those are the 7 strong acids. You'll notice that 3 of them are halogens, chlorine, bromine, iodine. These 2, of course, are related. We have nitrate and sulfate. So those are the 7 strong acids. On the other hand, our weak acids is another halogen, hydrofluoric, is not as strong as you think. And then again, we have your acetic acid, which when in the presence of water, you end up with, well, vinegar. We have carbonic acid and phosphoric acid. Again, this is in your Coca-Cola, which again is not necessarily very good for you. I'm not talking about the Coca-Cola, I'm talking about the phosphoric acid, but obviously it's still consumable, right? So please make sure you guys know those 7 strong acids. And again, what makes it a strong acid, like I said before, is the fact that when they are in the presence of water, they will fully or nearly fully dissociate, releasing the H+ ions. If they, by definition, by the Arrhenius definition, if they increase the concentration of H+ ions in the solution, then that would be an acid, okay? Remember, that means that they would feel squeaky, they would taste very sour, their pH would be measured to be less than 7, somewhere between the 0 to 6 range. And of course, they would be corrosive and react with metals. If I had a blue litmus paper and I dipped it into an acidic solution, that blue litmus paper would turn red, okay? All right, guys, thanks for watching. That is all about your acids.